And to find the determinant of a 3 by 3, it's a totally different process than how we did the 2 by 2. Okay, yeah. Yes, everybody turn them in over there. Okay, so here we have a matrix A, and you have 3 rows and 3 columns. To find the determinant, you do this. You reproduce column 1 and column 2 on the left of the matrix. So you see column 1 here is ADG. You rewrite ADG here. And BEH, you put BEH here. Okay? Now, no, just the first and second columns. Only the first and the second columns. The thing is you want to have 5 here. Now, okay. So now you draw diagonals. Okay, so look, you draw one diagonal this way. Oops. One diagonal this way, 2, 3. Does everybody see that? Okay. And what's on that first diagonal? A, E, and I, right? So you multiply everything that's on that diagonal. A times E times I. And then B times F times G. C times Z times H. Like on the, yeah, on that whole diagonal. And then you do the same thing this way. 1, 2, 3. So it's going to be a crisscross. You're going to have 6 total diagonals. And on each diagonal, you multiply each of the terms. Now, so look down here. You have arrows going to the right. Yes? There are 1, 2, 3 arrows going from left to right. You add whatever you got from those arrows. How many arrows do you have going to the left? 3. You subtract whatever you got from those arrows. It is a little weird, but oh my God, look, it's so much fun. So watch. It sounds confusing, but once you do it, oh my God, like it's so much fun. Okay, so watch. So I'm gonna reproduce the first 2 columns here, right? So -3, 1 minus 1, 2 minus 1, 4. Now, I'm going to do my first diagonals. So look, 1, 2, 3. Okay, now, there are 3 diagonals. I'm going to multiply all the numbers on each diagonal. So here's how you do it. On each, okay, so on the first diagonal, you have -3 times -1 times 0. And then you do plus. Now, what do you have on the second diagonal? 2 times 2 times -1. Right? Plus, what do you have on the third diagonal? Okay. Now I'm ready to do my other diagonals. 1, 2, 3. These ones, you're going to subtract though. So I do minus first, then I go to the matrix and multiply. What's on that first diagonal, the blue one? 4 times -1 times -1, right? Minus, and I go back. -3 times 1 times 2 times 4. Minus 210. Does that make sense? It's just in one line, and now we're just going to add all of them and subtract and add. Yeah. Yeah. Isn't that cool? Come on, it's cool. All right. So here you get 0. Here you get what? So it's 0 minus 4 plus 16. What are we going to get from this whole thing? Minus 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 is -4 plus, there are 3 minuses. It's minus minus minus. And then -0. At the end of the day, you get 16 minus 8 is 8 plus 24, 32. Where is it -6? I'm getting 32. What do you guys think? 32. So that's the determinant. Should we do it again? Let's do one more. So what am I going to reproduce here? The first two. So 3 minus 2 and 1 and 1 and minus 1 and 2. Yes? Yeah, yes? Okay. So here, let's draw our diagonals. Here's 1 and 2 and 3. All right, so what are we going to get from the first diagonal? 3 times negative 1 times 5 plus 1 times 4 times 1 plus 0 minus 2, 2. Now we're going to go in the other direction. Oh no, what did I do? Hang on. Yes.
For the first diagonal going right to left, is it 4 times negative 1 times negative 1? Doesn't that make negative 4? Oh wait, no. So like, where it says 60 minus 4, are you adding a negative or are you subtracting?
Which problem are you in, the first or the second?
I guess the first. I'll go negative 10.
Which one? Where?
Like, it doesn't matter which problem it is, but like, are you adding negative 4 or are you subtracting positive 4?
Here?
Yeah.
You're subtracting positive 4. So that's why it's minus 4. Okay. All right, so what do we have here? So the blue one now, it's going to be minus 0 times negative 1 times 1 minus 3 times 4 times 2 minus 1 times negative 2 times 5. Negative 25 for this one. So let's see. Here we get negative 15 plus 4, 0, 0, minus 24 plus 10. Right? So that's negative 12 plus 10. What did you guys get? Oh, that's negative 25. Okay. So now, some calculator stuff. Okay, so take out your calculators. Yes. Okay. No, it needs to be a graphing calculator.
I know how to do one of those.
Now, a little caveat, or just a little preface. You will have to be able to do, so far, whatever we've done so far, you have to be able to do it without a calculator.
But is it possible to do it?
It is possible. I'm going to show you how to do it with a calculator. But I'm going to be checking for the work. And sometimes they're going to be calculator proof questions. Okay? So, here's what we do. We press second matrix. You know what? Let me clear this. So, we press second matrix. Right? Is everybody on that page? Now, when you want to input a matrix, you have to scroll by pressing the right arrow. You see, like each one of the ones in the tab in the top are tabs. You have to go to the edit tab. Now, I want to put in a matrix for slot A. So you press 1 or enter to select A. You want to put in the dimensions. The one here, right, my first one here is a 2 by 2. So you say 2, enter, 2, enter. That's a 2 by 2. Now you want to put in your matrix entries. A little word of caution. So, okay, so it's 5, 7, 8, negative 2. So if I do 5, enter, right, as you keep pressing enter, it goes across the rows like this. Okay, so 5, 7, enter, 8, enter, negative 2, enter. If you want to go down and not across, you don't press enter, you just press the down button. Okay? Now, We want to edit, so we're here now. We want to exit the matrix editor by selecting second quit. So second quit. Now we're back in the home screen. Now you have your matrix in there. After this, now you're going to choose what to do with the matrix. So here, I want to find the determinant. You press second matrix again. Right arrow for the math tab. The first one is determinant. That's what I want to do. I want to find the determinant of a matrix. So either press 1 or enter. Now it asks you, okay, determinant of what? To select a matrix, you go second matrix. I want to find the determinant of A, number 1. 1, close, enter. That's the determinant. You probably pressed something wrong. I'll be over in a minute. So, determinant, that's a little bit more complicated, but you don't have to clear it. You could just edit it. So this is negative 66. What if we had done it by hand? It would have been this times that, negative 10, minus 56, and that could have totally been negative 66. Actually, for this one, if I'm starting from scratch, it's easier to find it by hand than, to waste all this time plugging it in, right? But that's how you would do it. Okay, now, what we're going to do is second matrix, edit. And I'm going to edit that first one, A. So I'm going to do 3 by 3 now. Okay, so 8, negative 2, 1, second, and mode, the one next to it. 6, negative 3, 2, 0, 6, 4. Okay? Now, let me show you something else. Second quit. In the previous operation, I found the determinant of A, right? And I want to do the same thing now, right? All I need to do is press enter, and look, it gives me just press enter. Because I had already put in determinant of A before, right? So I just pressed enter, and it automatically repeats the operation.
I just did it for determinant.
So I'm gonna double it?
Double what?
What did you get doing the second round?
And then how do you get rid of that? You clear the memory.
Yeah, but then you clear everything else too. You know what I mean? Okay. Now, how about to find an inverse? So on your tests and final exams, I'm going to have you find the inverse of a matrix. I'm going to have you find the inverse of a 2 by 2 by hand. The inverse of a 3 by 3 is just brutally long. There's just no point to do it by hand. You have to be able to do it with a calculator. There is no other way to do it. So if anybody does not have a graphing calculator, you do need one. Seniors, you need one for the final. Okay? All right. So we're going to put in our matrix again. We're going to put in this new matrix now. So it's negative 1, negative 2, 1, 4, 0, 3. Negative 3. Whoops, this was a 3. Negative 3, 1, negative 2. Second quit. Okay, I'm just going to clear this for a minute. To find inverse, it's here, right? So you do the second matrix, press 1 and enter. So we just did that one. Now it says press second. Oh, wait a minute. Sorry. I pressed enter twice. Let me do it this way. Okay, so you press 1 here. Now it says to press second and X inverse. So second And x inverse, it happens to be the same as the, wait a minute. Sorry. It's not second, it's just this. Yeah. Enter. But this is not what we want. You then have to go math, fraction, enter. That's what we want. So here, it's not second, it's just x inverse. So A inverse is equal to negative 1 over 3, negative 1 over 3, negative 2 over 3, I will not accept decimals in this, right? It has to be in fraction form. All right, so go ahead and do the next one, please. I'll stop this for a few minutes. Go ahead and do the next one. When we plug this one in, the determinant of this is 0. That means the determinant is 0. That means there is no inverse. Remember what we had said? The term for that is singular. You can either say no inverse or singular. It's up to you. Now, here's a random triangle. We know the vertices of the triangle. All right? You want to be able to find the area. Basically, so area is half times base times height. To calculate the height and all that, that's just a pain in the neck. Another way to do it is this. We write this as a matrix, okay? So I'm gonna call this matrix T for triangle, okay?
Yeah, I have a question.
Yeah.
To do this, could you solve this not in a matrix way? If you want to do that.
I want you to do it this way. There is a way, but I want you to do it this way. It's not though, because it would not be perpendicular.
Because if you mark, that's like one side of another triangle exactly, so if you find that side and then
But you have to be able to do it using, it's easier with a matrix. So watch. What we're gonna do is we're gonna write these coordinates. 1, 6. Okay? And then this one is 6, 4. And this one is 2, 0. Yeah, no, the order doesn't matter. But just write them like this. Now, we need to make this a 3 by 3. I'm missing a column. For that missing column, I put in ones. Why ones? That's the rule. Can it be anything else? Nope, it can't be anything else. Can you please close your computer until we finish this one? Okay, now the area of the triangle is equal to 1/2 the determinant of T. Now, here's another question for you. Can area ever be negative? No. Determinant can, but area cannot. So to fix for that, we take the absolute value. All right? So even if it was negative, just make it positive. Okay? So, no. You have to. It's 1/2 determinant. So now, let's put this in our matrix. So 1, 6, 1, 6, 4, 1, 2, 0, 1. Is that it? Second quit. Okay, so look, I already have in here from the operation before determinant of A. All I need to do is do what? Press enter. And it gives me the determinant. So the area is 1/2 of negative 28 in the absolute value. So how much is the area? Positive 14. Okay? How to plug in the matrix? Okay, I'll be right there. Are there any questions on this?
Yeah.
Yes.
I'd do the half.
That's part of the formula. Well, 28, half of 28 is 14. I just did it mentally. Okay?
When is this one?